Hi, welcome to the lesson on comparing fractions. We compare fractions by using the least common denominator, or what's known as lowest common denominator, which is LCD for short. And in this lesson, we'll use least common denominator, or LCD, and basically that's the least common multiple, or LCM, of the denominators. And by the way, LCD is the smallest number of all the common multiples of the denominators of two or more given fractions. But here, before we dive straight into the meat of this lesson, I would like to go over comparing fractions by using area models. So as you can see here, we have two area models. They are attached to each other. So this one is represents 4/5 because we have 4 out of 5 that are shaded. And then this one here is representative of 2/3 because we have 2 out of 3 shaded parts. Okay, and when we compare fractions, we use inequality symbols such as greater than, less than, and equal to. All right, and so for these examples here, I place 4/5 and 2/3. So what we're going to do is compare the two area models. And 4/5, is it greater than, less than, or equal to 2/3? And by looking at the area models, you can actually tell that there is more area that is covered by this first fraction area model here than the second one. So what this tells us is that 4/5 is greater than 2/3, right? Because more of the area is shaded, all right? So that means 4/5 is greater than 2/3, as I've mentioned. All right, so now let's go ahead and move into the meat of this lesson. So I'll go ahead and clear this out. And let me go ahead and remove the area models. So now let's go ahead and compare 2/3 as well as 4/5. Okay, so we're going to compare to see if 2/3 is greater than, less than, or equal to 4/5. Of course, we already know the answer to this, but I want to show you how this is done by using the algorithm or the procedure. Okay. So what we're going to do here is find the least common denominator of both 3 and 5. So the common denominator here would be 15. And the reason why that is because the both denominators are prime and they're small enough to where we could just multiply them to get the least common multiple, which in turn is the LCD. All right. So let's go ahead and multiply by 3 to make it 15. Whatever you do in the denominator, you must also do in the numerator. And then 5 times 3 is 15. So multiply by 5 in the denominator and numerator. All right, so now we have 15 as the denominator, 15 as the denominator. All right, so 5 times 2 is equal to 10. 4 times 3 is equal to 12. So if you take a look here, 2/3 is less than 4/5. And the reason why is because if you take a look at the numerators of both fractions, and by the way, these are equivalent fractions, meaning that they have the same value, all right? 2/3 is equal to 10/15 or equivalent to it, whereas 4/5 is equivalent to 12/15, all right? But anyway, by the way, as you can see, 2/3 is less than 4/5 because taking a look at the numerators, that's all we have to compare are the numerators, all right? Okay, so now let's go ahead and compare some other fractions where it's not easily detectable just by find out what the LCM is, okay? So let's wipe this out. And let's compare 5/12 and 7/18. All right, so we need a common denominator for both 12 and 18, or at least common multiple for 12 and 18. All right, so what we're going to do here is use the ladder method. Okay, so for 12, we will divide by 2, which gives us 6. 6 divided by 2 is 3. And then for 18, we'll start with 2. So 18 divided by 2 is 9. And then 9 divided by 3 is 3. Okay, so the next thing to do is rewrite the prime factors or prime numbers in exponential notation or in exponential form. So we have 2 squared times 3. All right, and then we have 2 times 3 squared. And so remember, we find the LCM by multiplying the highest exponent or power of each of the prime factors of the given numbers. All right, so let's go ahead and do that now. So the largest exponent on the 2 here is 2. All right, so we don't need this one because this is 2 to the first power. So we have 2 squared times, and the largest exponent is it 3 to the first or 3 squared, and we know it is 3 squared. So now we can continue to multiply. 2 squared, which is essentially 2 times 2, which is 4, times 3 squared, which is 3 times 3, which is 9. And 4 times 9 is equal to 36. So that means our LCM is 36, which in turn is our LCD. All right, so they're one and the same. That's how I look at it. All right, so now we need to convert the denominators into 36. So 18 times what number gives you 36? And that's 2. So we're multiplying by 2 in the denominator as well as in the numerator. All right, we're doing the same thing with 5/12, but 12 times what number is 36? And that's 3. And we'll multiply the numerator by 3 as well. So now we have like denominators. All right, so this will help us to compare the fractions. All right, so we have 5/12, which is equal to 15 over 36, and then we have 14 over 36, which is equivalent to 7/18. So now we can determine, or we can compare fractions. So 5/12 is greater than 7/18 because notice it's equivalent. 15 over 36 is larger than 14 over 36. So that means 5/12 is greater than 7/18. All right. So let's go ahead and move on with a couple more examples here. Wipe this out. Okay, so let's take the fractions 7/8 and 7/9. So we'll also compare these fractions using the inequality symbols here. So I like to think of it this way because we can actually compare 7/8 and 7/9 without finding the least common multiple because we have numerators that are the same. And when you're comparing numerators that are the same and you have unlike denominators, the fraction with the smaller denominator will have a larger value, whereas the fraction with the larger denominator will have a smaller value. So I usually like to use the statements less is more. So less is more and more is less. Okay, so remember, this only works when the numerators are the same and the denominators are different. All right, so like I said, your the fraction with the smaller denominator will have the larger value, and the fraction with the larger denominator will have a smaller value. So that means when you're comparing both these fractions, that means 7/8 is greater than 7/9 based on these two phrases. Less is more, more is less. Okay, so hopefully that was helpful to you. And last but not least, you can also compare fractions by using cross products. All right, so let me show you what I'm talking about. Let me wipe this out. So let's say you have the fractions 2/5 and 4/10 that you need to compare. All right, and so what we're going to do is cross multiply. That's all you're doing. That's what it means. That's what cross products means. It just means to cross multiply. All right, so 2 times 10 is 20, and 5 times 4 is 20. So that means 2/5 and 4/10 are equivalent fractions. So we can label it as such. So we can say 2/5 is equal to 4/10. Okay, so that's all we have for this lesson. Hopefully it was helpful to you, and I look forward to working with you in the next lesson. Take care.